Welcome to February 12th LeetCode Challenge. Majority element. Given an array nums of size n, return the majority element. The majority element is an element that appears more than the n divided by n by 2 times, which is the lower bound. You may assume that the majority element always exists. In example 1 here, we have an array of nums containing 3, 2, 3. The majority element would be 3 because 3 is the majority element in the array. Similarly, we have the majority element of the array 2, 2, 1, 1, 1, 2, 2. We can tell that 2 is the majority element because 2 exists more than one time. Exists more than one. Our constraint is that the length of nums is n, and n would be between 1 to 5 times 10 to the 4. And each index of nums value is any value between negative 9, 10 to the 9, and 10 to the 9. Can we solve this using linear time and constant space? I think we can. Alright, so the problem requires finding the majority element which appears more than the lower bound n divided by 2 times in the given array. So it's a well-known algorithm for solving this. A well-known algorithm for solving this is called the Boyer-Moore voting algorithm. So, which is a key insight into that if we cancel out each occurrence of the element in the other elements that are different from it, the majority element would be the one remaining. So if we take all the elements here and we cancel, for instance, 2 with 3, if they are the same index, the same unique values, then the remaining element will be the one that has the majority, which would be 3. Similarly here, we cancel 1 and 2, 2 and 1, so we cancel this entire thing. So using the Boyer-Moore voting algorithm, and we cancel these two, then the remaining element would be 2. So our approach is going to be, we're going to initialize two variables called result and count. Let's do that right now. So int results, and let's say equal to 0, and we have an integer called count as well. It's equal to 0, and we're going to iterate through. So basically, initialize two variables, results and count, to keep track of the potential majority element and its count. The next thing we want to do is iterate through the number of integers in nums. So for int n in nums, what we're going to do is if the count is equal to 0, set the results to the current element. Let's do that. If the count equals 0, set the results to the current value. I think we could probably do this on one line. Else if the number of elements, current element, is equal to results, increment the count, otherwise decrement the count. So what we're going to do is count increment. We're going to increment it by 1, so n is equal to results. We're going to use a ternary operator here, set to 1, otherwise set to -1. Therefore, we're going to increment or decrement accordingly. At the end of this, we want to, after each iteration of results, variable should hold the majority value. And then, at the end of this, we want to return results. I'll take this for a run. Semicolon there, semicolon here. Seems to be accepted. Let's go. Excellent. So what we did is that we used kind of the Boyer-Moore voting algorithm to find the insight that if we cancel one value of the same index, if we cancel a unique value, all of the unique values initially, then we can continue iterating through that until the remaining value is the majority value. So what we do is we initialize two variables, result and count, to keep track of the potential majority element and its count. Next thing we do is iterate through the array for each element. We find if the count is equal to 0, reset the result to be the current element, If the current element is equal to the results, then we increment the count, otherwise we decrement the count. And after each iteration, the result of the variable should hold the majority element. Time complexity wise, we have big O of n as the algorithm iterates through the array once. Space complexity is also constant space because we only maintain the constant number of variables. And that is it for this one. Alright, have yourself a great day.